Hello and welcome to Andy and Ian Talk Networking, and welcome to another interesting and insightful discussion. I am Andy,
And I'm Ian.
and today, Ian, I want to talk about kind of the next level up, if you like, in the observability stack. So we've spent quite a bit of time talking about taps and spans, and we've had a number of discussions about packet brokers and tapags. But really, I think the next level up is quite an interesting one, which is now that we've got this data off of our network, what do we do with it? Um, and it's kind of okay, great, big deal. So you've sent all this data to me. What am I actually going to do, and what am I going to understand what all is going on with all this data? And really, that's the packet capture portion of the observability stack. So let's start off really high level. What is packet capture?
Okay, well, let's start with the
Get in
basics.
there. Get in there.
The key thing is that packet brokering, right, is an infrastructure element, right? It's getting access to the packets and distributing them out to tools. One of the tools could be a packet capture system. That's the idea of taking packet data, or at least a portion of the packet data, and storing it for a period of time on a device. Could be a software appliance, but obviously, generally speaking, it's a hardware appliance. So it's pretty simple. It's the idea. It's a tool rather than kind of a full infrastructure kind of idea. It's a target, and we're going to capture all the packets, most of the packets, the headers of the packets, all kinds of interesting discussions in those areas. But the bottom line is we're going to put those on the disk, and we're going to do some analytics, and we're going to be able to recall those for the needs of the customer.
Okay, so effectively we're taking all this data, and that's an interesting point because people, when they think about capturing stuff to disk, they think about their PCs and their laptops, and they're thinking about a couple of gigabits. Okay, great, but in a large corporate network you could have 24 or 48 or hundreds of ports of 100 gigabits. How do you deal with that problem? Because now you've got immense amounts of data, which is not just going to fit on a little 256 gig SSD drive. You're talking massive amounts of data. You're talking huge speeds of data. You've got them coming from multiple locations that have got to be put in some kind of an order.
Yeah.
How do you handle all that? Carefully, really
I think
carefully.
that's exactly it. That's the joke I couldn't quite get to, Andy. But yes, exactly, carefully. No, it is a huge question, and this is one that we get regularly, right? I'm sure anybody on this who's taking a couple of minutes out of the day to watch this video is asking the same exact thing. Point is, you've got to know exactly how much data you want to capture. Yeah, you
Yeah.
can have as many 100 gig links as you want, so to speak. But actually, if they're being highly underutilized and it's really a connectivity play,
Hmm.
then there's probably plenty of room. If you really are capturing at 10 gig, 40 gig, 100 gig, 200 gig, whatever,
Yeah.
that's at wire speed 24 hours a day, you're going to fill up air quote those disks, or
Yeah.
storage, I should say. You're going to fill them up pretty quick. So you need to really be very, very clear as to what you are doing. Do you just want the headers? Do you
Right.
care about the payload? Should you be using some kind of filter in your packet brokering layer to chop off those payloads from the packets and all of these things? Are you trying to actually be able to replay those packets later? Right,
Right.
but that's another huge decision that needs to be made, because if you are ever thinking to be able to go back and replay those packets, you need to make sure you got the whole thing.
Yeah.
If you're just doing the analytics, just that's not underplaying it, but if you're just doing analytics, yeah, probably just the headers might actually be enough. So there's a lot of big decisions that you, as the consumer, as the user, need to make about how you perceive what you're going to do with this. If you're just doing forensics, as an example, as one use case,
Yeah.
forensics, you can then go back and look like a kind of security video kind of style and say,
Right.
wow, hey, something happened last Tuesday. I get a good
Such a window.
feeling
Yeah.
for it.
Yeah.
Yeah, exactly. But the point isn't to do live analytics and looking for reds
No.
and
No.
greens and ambers and everything else. You're just looking for it like like a kind of security video concept. On the flip side, you could be doing only analytics and you're just looking for kind of green, amber, red, that
Mhm.
kind of style. And that's a totally different use case. Again, you don't need really a lot of retention. You're just looking to be able to understand
Yeah.
exactly what's going on in the sessions. So anyway, yeah, so lots and lots and lots of things to unpack in that
Yeah.
subject.
Yeah, and I think there's a couple of key things that when I think about it, originally I used to just think, oh, you throw a drive, throw some drives in there and you'll be fine. But actually, when you start digging into it, there's a lot of things you need to consider. Things like, what's your burst rate look like versus your
Hmm.
sustained rate. So you could have a situation where most of the time, you've got in your network, just for argument's sake, say you've got 40 gigabits worth of traffic generically just bouncing around there. But there could be certain periods of the day where you've got huge spikes of traffic going on for short periods of time. So you need to have your packet capture has to have that ability to deal with those bursts. Otherwise, you end up with packets being dropped. But then when I start thinking about the analytics side of it, there's other things that you need the rest of the network to provide. We've talked in the past about compliance and timestamping. You need that information. If you've got 64 ports of 100 gig feeding into your packet capture, you need to know exactly the order that those packets came into your packet
Yes.
capture device. Otherwise, your analytics tools are just analyzing garbage, basically. So yeah, I
Yes.
kind of look at it. There's a lot of other kind of key functions. But one of the other things I always hear is, oh well, I'll just put a RAID 5, one use server in there. Okay, but that has its own problems. And when I start thinking about the analytics and packet capture, your typical file storage has different sets of problems versus your observability data. So can you just dig in a little bit and kind of explain why we don't use things like RAID 5 or, for example, in a packet capture environment? What are the kind of corner cases as to why we don't kind of just go ahead and use something like that?
Yeah, this was 3 hours, not 10 minutes, Andy,
Yeah,
right?
yeah.
That's what we're going for. Okay, so yeah, I mean, let's tackle just pick one tiny little slice out of all of that. The bottom line is things like RAID. The key trick is RAID is designed for long-term retention
Yeah,
systems, right? That's
yeah.
that's what it's designed to be able to do. Regular writing, but generally speaking, it's long-term storage. Pictures of your favorite cat, right? That kind
Dog,
of stuff.
dog. Don't
Sorry,
do
sorry,
cats,
sorry,
dogs.
sorry, sorry, sorry,
Not
dogs.
that I dislike cats, but we're a dog family.
Okay. Your favorite picture of your dogs. Bottom line is you want to retain that for
Yes.
many years to come. So RAID makes a lot of sense. If I'm doing a capture system where I've actually got high levels of write, and
Hmm.
actually it's not actually about long-term retention,
Right.
then effectively RAID
Yeah.
adds a level of overhead and complexity as well as waste
Yeah.
on the storage side that isn't actually necessary. And by the time if you did have in the event of a disk failure in a RAID
Yes. Yeah.
system,
Takes
you're going to
days to
take,
build. Yeah.
yeah, well, it's going to take longer to rebuild than effectively the retention period on the drive.
Right.
So effectively, you're going to end up with, yes, you'll have a full set of systems, but
With
you'll have
obsolete data.
you
Yeah.
obsolete data and you'll have reduced your capture rate during
Yeah.
the entire life of that rebuild.
Yeah.
Bottom line is put as many disks in as you can, effectively assume there'll be a certain failure rate, and
Throw
just
them away.
basically
Yeah. Carry the data. Yeah.
carry right along.
Okay.
And so I think that's a big one, and I get asked that
Yeah.
pretty regularly, and it's certainly a question that I would make sure you ask your vendor is to understand, and I just will tackle one of the other things you highlighted, which was capture rate, burst rate.
Yes. Yeah.
It's really important to find a vendor who's prepared to stand behind their capture number, whatever that number is. I don't care if
Yeah.
it's a million billion terabits per second,
Yeah.
doesn't matter. Get a vendor who's actually prepared to offer you a number, not port connector speed on the
Yes.
back.
Yeah. What's your
What is
actual
the
rate?
actual capture, both for burst,
Yeah.
yeah, absolutely, as well as for sustained
Yeah.
capture.
And if you
And
could get
I've
independent verification of those numbers as well, that's always an extra value. Yeah.
completely right, Andy. No question at all on that. The point is, you're looking for a vendor that you can trust. You're looking for a vendor who states numbers, that's prepared to live and die in some sense by those numbers.
Yeah.
And the point is that many vendors out there are not prepared to do that because they just actually don't know
Yeah.
the answer. So
And
anyway, yeah,
that's
sorry,
that's
Andy.
actually an interesting one because I've seen a number of vendors who will state the hardware's capability, So, oh yeah, but I've got X lanes of PCIe, 10X or something, and therefore I can do this. But actually, they won't tell you what their sustained and burst capture rates are, because there's software on top of that. There's, other network components. There's a whole range of other components in the system that dictate what that is, not just one interface or one specific, interface characteristic.
Completely agree, Andy.
Yeah.
Completely agree.
Okay, that's great. I think we're pretty much out of time. Again, thanks for the time, Ian. It was, as always, good to talk to you. And please, again, let me remind everybody, please don't forget to like and subscribe if you enjoy our content. It helps us to understand who and what you guys are finding interesting. And again, if you have other topics that you'd like Ian and I to discuss in the future, then again, please drop us a line through LinkedIn. You can find us both on LinkedIn or in the comments section below, and we will be more than happy to discuss those with you in a future call. So appreciate your time. Thanks everybody for watching, and we'll see you again next time.
Bye for now.